Hey everyone, today we're going to be talking about Pythagorean Theorem, specifically Pythagorean triples. You'll learn how they can help you quickly find missing side lengths in right triangles, and then later in class we'll solve some word problems using right triangles. First off, the definition of a Pythagorean triple is that it is an integer or a whole number solution to the Pythagorean theorem, a squared plus b squared equals c squared. That means you'll get no decimals, no radicals you have to reduce. They'll be whole numbers. Here are some common Pythagorean triples. I highly recommend you memorize the top row. We've got 3, 4, 5. In other words, 3 squared plus 4 squared equals 5 squared. 5, 12, 13, 8, 15, 17, 7, 24, 25. Then you'll notice as you go down each column, they're multiplying each number by something. Here they multiplied 3, 4, 5 by 2, 3, 4, 5 by 3, by 10, and so on. And they're doing that in each column. For our first example, we want to find the unknown side length using the Pythagorean theorem, then show how to reduce it to its common Pythagorean triple. So the first thing I'm going to do is set up a squared plus b squared equals c squared. X is on my hypotenuse because it is across from my right angle. So that must be plugged in for c, and then you can plug 9 and 12 in for a or b. So I've got 9 squared plus 12 squared equals x squared, which means 81 plus 144 is x squared. Combine your like terms, 225 equals x squared. Then to undo the squared sign, we have to square root both sides to get x is 15. So that leaves me with my three numbers, 9, 12, and 15. Now what I'm going to do is I'm going to see what all three are divisible by. I can see here that all three numbers are divisible by 3. When I divide 9 by 3, I get 3. 12 by 3, I get 4, and 15 by 3, I get 5. In example number 2, once again, they want me to find the unknown side using the Pythagorean theorem, then reduce it to its common Pythagorean triple. So once you solve for x, you're going to line up all three sides and look for a number that they are all divisible by. Once again, x is my hypotenuse because it's across from my right angle, so that must be plugged in for c. 14 and 48 can be plugged in for either a or b. So we've got 48 squared plus 14 squared equals x squared. Now when you square both those numbers, you get 2,304 plus 196 equals x squared. Combine your like terms and you get 2,500 equals x squared. Square root to get rid of both, and that leaves you with x squared equals 50. So that leaves me with 14, 48, and 50 as my three numbers. They're all divisible by 2, which gives me 7, 24, 25, which if you notice by scrolling up is one of our common Pythagorean triples. Now, for numbers 3 through 6, the given lengths are two sides of a right triangle. So we already know these are a right triangle. All three side lengths of a triangle are integers, and together form a Pythagorean triple. Determine the length of the third side and tell whether it is a leg or a hypotenuse. So in order to do this, what I'm going to look for first is what are both of these numbers divisible by. 51 and 24 are both divisible by 3. When I divide them both by 3, I get 8 and 17. So now I'm going to come back up to my triples, look for one that has 8 and 17. Here it is. The only number missing is 15. So that must be my missing side. Now I have to determine if it's a hypotenuse or a leg. 15 is not my greatest number, so it must be a leg. Remember, your greatest number is always the hypotenuse. Now, in order to find out what the measure of the actual side is, I'm going to multiply by the same number I divided by up here. We're going to take 15 times 3, and that's going to give us 45 for the length of that leg. Now in number 4, I've got my two sides are 20 and 25. Right away I see they're both divisible by 5. When I divide them both by 5, I'm left with 4 and 5. When I come back up, here's my common Pythagorean triple with 4 and 5. The missing number is 3. So that means that 3 represents my missing side length. Since it's not my largest number, I know it must be a leg, not a hypotenuse. Now to find the measure of the actual side, I'm going to multiply by the same number I divided by. So I'm going to take 3 times 5 to get 15 for my missing side length. For number 5, 28 and 96 are both divisible by 4. When I divide them by 4, we get 7 and 24. The common Pythagorean triple number that you're missing is 25. Since that is the largest of these three numbers, that means it's the hypotenuse. Then I'm going to multiply 25 times 4 to get that my missing side length is 100. Go ahead, pause the video, take a second, and try number 6 on your own. 20 and 48 are both divisible by 4. That leaves me with the side lengths 5 and 12. 13 is the common number that's missing. It's the largest of these three, so it must be the hypotenuse. Then to find the actual side length, we take 13 times 4. That is all the new information we are doing for today. We'll do some more practice in class. Have a good evening.